Emilia Tolbert from Jacksonville.
Tuskegee University.
And her topic of presentation is an assessment of groundwater vulnerability using Drastic, I think it is acronym, a case study in Elmore, Macon, and Tallapoosa counties.
Thank you for that introduction. For those that may not have heard, my name is Emilia Tolbert, and I am pleased to present my research entitled An Assessment of Groundwater Vulnerability Using Drastic, which is a case study in Elmore, Macon, and Tallapoosa counties. The presentation will proceed accordingly. Groundwater is an essential component of societies and communities around the globe. Not only is it a vital resource for drinking water, it is also essential for social, recreational, and cultural activities. It is estimated to be the most extracted natural resource around the globe, with extraction rates of 1,200 cubic kilometers per year. It is mostly used for crop irrigation as well as domestic uses. In Alabama, groundwater serves as a reliable drinking water source for approximately 44% of residents, serving 285 water systems for approximately 1.46 million people. It is a well-known fact that approximately 70% of the earth is covered by water, so oftentimes we begin to think of water as a limitless resource. However, only 0.6% of water is groundwater that's available for human consumption. This multi-layered pie chart depicts this best. 97% of the total water quality is found as salt water, while only 3% of that is found as fresh water. Of that 3%, approximately 87% is frozen as ice in glaciers, 1% is found as surface water in rivers and lakes, and approximately 12% is found as groundwater for our consumption. So as you see, we already have a limited supply of groundwater. However, it continues to face many threats due to natural as well as anthropogenic activities. This reduces the suitability of water for domestic uses and poses a threat to environmental as well as human health. This brings us to the need for groundwater assessments. The problem found in this research is one that's common to many communities around the globe. It begins with a desire for a community to increase economic development. This also increases the need for clean groundwater. However, as economic development begins to increase, this also increases the amount of waste within the community, which can lead to an increase in groundwater pollution. That ultimately leads to a lack of economic growing capacity, meaning that the environment has hit a peak where it can no longer sustain a growing community. Therefore, the justification or the statement of purpose for this research is to maintain and manage our limited supply of groundwater in a way that will prevent future contamination, to encourage land use capacity, economic and technological development within the study site. The sub-justification bullet points are to support aquatic regulation for drinking water quality, to prioritize vulnerable areas that are more susceptible to contamination, as well as to direct resources to the appropriate areas that need it the most. There are 3 objectives of this research. The first is to determine aquifer vulnerability in 3 counties within Alabama. Second, I will specify the levels of contamination within the study site. And lastly, I will identify key sources of pollution within the study site. This will be conducted using the Drastic model. The Drastic model is a model developed by the Environmental Protection Agency, or EPA, to standardize and simplify a way that researchers could assess groundwater quality within a region. It uses 7 hydrogeological factors to do so. The hydrogeological factors are simply the natural factors within the environment that govern the flow of groundwater. This is also going to be managed in a GIS, or Geographical Information Setting. For anyone who isn't familiar with GIS, essentially it allows you to input data such as street data, buildings, and vegetation, and overlay those data to conduct spatial analysis. The 7 hydrogeological factors that I spoke of are as follows. Oftentimes, it's hard for us to visualize how these factors actually play out in space and time. So this diagram depicts just that. The depth to water table parameter is simply the distance from the top of the ground to the top of the water table. This determines how long it will take a contaminant to infiltrate and get to the groundwater. Essentially, the longer time it takes for the greater distance, the longer time it will take, the less vulnerable that would be to contamination. The net recharge is the total quantity of water that reaches the ground table after precipitation. Aquifer media is simply the rock that makes up the aquifer. Soil media is the uppermost portion of the earth, being that the more permeable the soil, the easier it is for a contaminant to infiltrate the soil to work its way down to the water table. Topography is simply the slope of the land, being that the steeper the slope, the easier the contaminant will run off. Versus on a flat surface, the contaminant will sit there longer and have a longer opportunity to infiltrate through the surface to get into the groundwater. Impact on Vados layer is simply the layer in between the soil and the water table, and it works similar to the soil layer, being that the more permeable this surface is, the easier a contaminant will infiltrate to get to the groundwater. And hydraulic conductivity is simply the horizontal flow of the water through the aquifer. My study site is comprised of 3 counties within Alabama, Macon, Elmore, and Tallapoosa counties, which together make up approximately 5,274 square miles. According to the U.S. Census, the study site is 95.6% rural land distribution. It's an agrarian-based economy with gentle slope increases towards the north of Tallapoosa. Alabama also ranks 8th for U.S. toxic release per square mile. The data that I will be using was found on government websites for each parameter. In addition to the 7 layers of data that I'll be using to conduct the Drastic method, I'll also be using water quality data as well as land use, land cover data. So as mentioned previously, the Drastic method is comprised of 7 layers that are pre-processed and reclassified to be put into a spatial database. From that spatial database, I will conduct a final vulnerability map. I conducted a final vulnerability map, which was reclassified to give a final vulnerability index. And this is done through a scale of weights, ratings, and ranges. So each parameter within the Drastic index is given a weight based on its importance or its influence on groundwater vulnerability. 5 having the most influence and 1 having the least influence. For example, depth to water has the most influence on the vulnerability of a region, while topography has the least amount of influence. From there, those categories are broken down even further into ranges. For example, if the topography of the site had a slope of 0 to 2%, meaning that it's a fairly flat surface, then it would be given a rating of 10, meaning that it is highly vulnerable because the contaminant would sit there longer, having more opportunity to infiltrate through the surface. Finally, the weights and the ratings will be put into the final Drastic index equation to give a final vulnerability index of the site. For the sake of time, I'll just go over a few of the data pre-processing and intermediate steps that had to be conducted in order to develop the final vulnerability map. This included searching for and gathering my data, clipping the data to the study site. Since some of the data came from the entire state of Alabama, it had to be clipped for my counties. Some of the data also came in pieces, so it has to be put together or mosaic together to be one cohesive file. The data had to be reprojected to a similar coordinate system. The vector data had to be converted to raster data. Values had to be calculated if necessary. The measurements had to be converted to one cohesive scale. And of course, I had to apply my ratings, the weights, and calculate the final vulnerability, after which I could conduct the statistical analysis. These are the results for the 7 parameters. This is the depth to water table. and the net recharge factor. Here's the aquifer media and the soil media, which was split into 6 classes. The topography, as well as the impact on Vados layer, as well as the hydraulic conductivity map. All of these 7 layers were put together to make a final vulnerability map, which is shown. The final vulnerability map showed a dominance of high vulnerability, especially within Macon County. It was shown that 97% of Macon County was highly vulnerable, which is the county to the bottom southeast. However, we see as we go to the northwest, there's less vulnerability within those areas, as well as areas that have less as well as we see clusters of less vulnerability around the north region of the map. So we found that 0% of the study area had very low vulnerability. 1.32% of the area had low vulnerability. 11% was moderately vulnerable. 8.7% was highly vulnerable, and 78.98% had very high vulnerability. So essentially, I took these values and just put them into a bar graph so that we could visualize this in another way. And so as we see, the bar graph depicts exactly what we just saw on the map. Next, nitrate values from 129 wells were plotted over this. We expected to see, in the simple linear regression, we expected to see that as the drastic index increases, meaning higher vulnerability, we expected that as vulnerability increases, nitrate concentrations will also increase. Here we do see a positive linear relationship. However, we also see that that's not always the case. There were parts where there were low vulnerability, however, there were high nitrate levels, which we weren't expecting to see, and this needs further investigation. However, we also see that same trend within the map as well. Next, I made a comprehensive list of all of the potential pollution sources within the study site. These range from hospitals to schools to domestic uses, and we overlaid this with the map to see if the high concentrations of nitrate values also coincided with the potential sources of pollution. We did, just looking and observing this map qualitatively, we did see a trend there, which needs further investigation as well. So overall, 78.89% of the study site was found to be highly vulnerable, and it was highly influenced by the topography map as well as the net recharge map. Nitrate concentrations were within the EPA limits, and the Drastic method generally gives satisfactory results. However, it does have rigidity in assigning weights as well as ratings to its parameters. Overall, this study produces a very valuable tool for policymakers, city planners, urban and rural developers. And it provides a preliminary step with vital information that can be considered. In the future, I would like to investigate environmental justice components of this study, expand the study site to map the entire state of Alabama, and explore other contaminant types such as heavy metal concentrations. I would like to acknowledge my advisors, my advisory committee, as well as my colleagues in the Geospatial and Climate Change Center Computer Lab. Thank you so much.
Probably we don't have much time left, but I will allow a couple of questions.